Shanti's sweet stall was placing an order for making cardboard boxes for packing their sweets. Two sizes of boxes are required. The bigger of dimensions 25 by 20 by 5 and the smaller of dimensions 15 by 12 by 5. For all the overlaps, 5% of total surface area is required. If the cost of the cardboard is rupees 4 per 1000 centimeter square, find the cost of cardboard required for supplying 250 boxes of each. So first let's look at this first picture here that I have. And in this picture, this first picture right here, this picture, we'll see what you mean by this overlap. Now, to make a cardboard box, as we have seen, you require, here see there is a cardboard box and there is a lid on the top. To make a cardboard box, you require TSA, which is 2, length, breadth height and length height. But here they mention something else, and they mention something called overlap. 5% is required for overlap. Now what do you mean by overlap? Look at the figure, the next figure. Here, have you seen this is little extra? It is double here. Have you seen for this lid? This is the overlap they're talking about. Now for this overlap, this is called the overlap, and you require extra for that. That is 5% of the TSA. So in making these boxes, we don't only require TSA, we require the TSA plus we require 5% of TSA for the overlap. So while working the sums out, we've got to take care, we need TSA plus 5% of the TSA for overlap. Now we have two kinds of boxes. One box is a small box. The length that I put in here, the length is 15 centimeters, the breadth is 12 centimeters and the height is 5 centimeters. And here we will require the TSA. So you put the formula for TSA, twice length, breadth height, length height, put the values in this case. So after you have put all the values of length, breadth, height, you do that calculation and you get this as 330 centimeters square. This is the TSA. But remember, we don't only require TSA, we require also the overlap. Now for the overlap, we require 5% of TSA, and that is given to us, 5% of TSA. Look up here. So overlap will be 5% of TSA, that is 630, and that works 31.5 centimeters square. So the total area required, area for the small box, will be TSA plus the overlap, and that is TSA is 630 and the overlap is 31.5, and so the total area required in this case is 661.5 centimeters square. In this similar manner, you are going to find the TSA of the big box. We have the big box, which is here. This is the big box. And in the same way, you have its length, breadth, height given. You will find the TSA by using the formula 2 length, breadth height plus length height. You will work it out and it will work out to 1450 centimeters square. Now here again we require overlap. This box requires TSA plus overlap. Now we know overlap is 5% of TSA, and that is 5 over 100 into 1450, and that works out 72.5 centimeters square. So that the total area required now for this box, for the big box, area for big box will be equal to the TSA plus the overlap. And we know the TSA is 1450 plus the overlap is 72.5, and that works as 1522.5 centimeters square. This sum is not done. They require 250 small boxes plus 250 big boxes. So that will be 250 into, so each small box is 661.5, and here 250 big boxes, and each big box is 1522.5. So we'll take 250 common out. It's easier to do it this way. 661.5 plus 250 is gone out. This also 250 is gone out, and 1522.5. So we add that, we get 250 into 2184. I won't multiply it, you will understand why. So this is the total area required. Now we need to find the cost. Now we know the cost equal to area into rate. Now the area is this, all the 250 boxes, 2 into 2184 into rates. Now if you go back and see, the rate is 4 rupees for every 1000. So for 1 will be 4 over 1000. They said rupees 4 for 1000 centimeters square. So for 1 centimeter square, it will be 4 over 1000, and that is the rate. So I'll write it out here again. Over 1000, and we strike this, we get this 250 now, and this 250 will cancel, 2184 rupees.